Okay, so yeah, that works out fine. Let's get this up. All right, let's make sure this is here. Okay. Oh, whatever. Last time I was talking about the determinant and how this is, but I just realized an easier way to explain it because I realized that if you have a 2 by 2, that also has a determinant, which is done by AB minus CB, and then you get the determinant like this, and which equals a scalar, which gives you an area of a 2 by 2 area. So, like we said, we could just define it this way: area of vectors, squared vectors. So, what does square matrix, not vectors, because vectors wouldn't make sense. No, it has to be vectors, although. All right. A determinant, I guess, then is a matrix with n vectors and n columns that you want, and that guess the area of the vector. I want to call it vector space, but it's not vector space technically. Vectors. What'd you call it? Term as wouldn't call that. You would probably call it a determinant is a matrix with n vectors and n columns, which just says it's an n by n matrix. Then it gets you the area of the area of the shape. So created by n addition. Why I say addition? It's probably a bad definition, but if you think about it, this is what's happening, which is basically A B addition if it's vector. So we should probably use another denotation: x vector and y vector. And then in reality, it's like this, where you do it like this. But kind of have to describe it better. Interesting. Yeah, that's probably the way I would describe it. And math, unlike science, has an objective reality because it's all perfect. Science is not perfect; it has errors everywhere. Uh, but one thing to know about math is that it is pure science. It has no basis on anything other than numbers, which basically means it's not racist, it's not sexist, it's not anything. It's just numbers thrown on a page. Um, you can manipulate data to make it seem biased, which is why statistics is the most biased math. But objectively, the pure mathematics cannot be, and it cannot be racist, cannot be sexist, cannot be anything. The people that argue that, I personally believe, failed at math and want to get revenge on math because they don't understand math, and or halfway given up on math. They went to the corporate. They went to like all of math, and in college they got so confused that they gave up. And that's why I feel like people that argue that math is racist or sexist believe the only way you can argue such nonsense is with statistics, which is why I think math is an objective reality except for statistics. So math is objective, except actually no, that's thinking about it. You could manipulate any math data. So if you do a linear fitting and try to make a correlation without causation, you can make it racist. But that is again statistics, right? You wouldn't say 2 plus 2 is somehow not 4. Yeah, that's a good one. Yeah. And which is why if I talk about math and I say necessary knowledge here, that's not where I wanted to go. I want to go over here. You'll see that what can make math lie, and you find that most of it is statistics. If you look at the answer for how does math have a book, this is a question I made, but it's oh, I didn't ask for that. Well, that's a mistake on mine. But in math, which discipline leads to errors and biases? I should say and biases. And biases. So in reality, let me copy and paste that over here. Let me copy and paste that over here. Oh, then we have to do oh, there's already an underlined piece over here. I just didn't notice it because um well, we could try to bold it. Hey, that worked. um, Errors and yeah, biases. So I guess most of math is objective. Reality is more closely reliant to what I'm saying, isn't it? Think about it. The more advanced you go with math, go with math, the more. Yeah, I'm not sure if that's even true anymore. Because thinking about it, the more advanced you go with math, the more confusing and biased it can be. But usually that is statistics, right? It isn't, you cannot use calculus as a way to say. So applied math can be biased. But I would always argue that math is objective reality if you're talking about something like 2 plus 2. And calculus, where you do integrals and derivatives, is objective reality, and you cannot deny these facts about life. Okay, now we're getting somewhere. We're getting to a situation that makes sense of what I'm trying to say. Yes, there's objective reality, and the people that cry about it feels like they're not involved with science too much. Right? No, science, on the other hand, has a lot of biases, and it can be racist, and it can be sexist. For example, medical. It's the most famous type. Physics is immune, is more immune to it. So now thinking about it, this is wrong. You can't say that. So again, science is the same boat as math. If you want to cry a river about it, you cannot say it's racist. You cannot say it's racist. I think most of science cannot be racist or sexist. Think about it. It makes no logical sense. Hard science, especially, so physics and chemistry, They're immune. They're literally immune to this. I'm just thinking about this because I just saw a video on it and thought, wait, is that true? Obviously not, because math is objective most of the part, and the hard sciences is. Now, if you go to psychology, I don't know how to spell psychology. Oh, another thing actually might be racist and sexist. It's probably the way you get into it, but that isn't the hard science discipline. It isn't the science that is racist or sexist because it cannot be. It is an objective truth. You cannot make it sexist or racist. It's a physical property world. No one cares about your objective beliefs. Beliefs are lies, not lies, but are not truths. Huh. I believe something is not valid truth. I like this idea. If I like this idea, it's a statement that you're referring to yourself, the individual. It isn't saying that you speak the truth. You're just saying your idea. It isn't you. It isn't true. If I said the integral of x equal 1, that is false. The integral of x equals x squared divided by 2 because of the power rule. And that will always remain true because the physical property of the world has it so that the integral of it needs to be something like this. You cannot deny that fact. Denying that fact is your fault and you're wrong to deny it. That fact cannot be changed. But no matter how many times you believe that, you cannot change the truth. Truth is truth. And you want this to be not true doesn't imply truth. And that makes a lot less sense than what my brain was thinking about. I was just thinking to myself, yeah, interesting enough. Why I'm thinking about this stuff was because a lot of my question I realized over here with government, I put the wrong answers in A, B, C, D, which I will have to change because I believe as wrong, and then this statement as true without any objective truth. I did that because I thought everyone knew that the objective truth was objective, and yeah, but this was partially me being lazy. But yeah, interesting. Yeah, I'm not gonna change some of them. I'm just gonna leave some of them. But yeah. Um, All right, let's go back to calculus because I last time I wanted to talk about something in math that was so. Oh, those are my artworks, not language arts. Not. Oh, you want to try to test all topics? This is a test I made for laughs and giggles. That it really doesn't matter. You can try it if you want. It is I doubt a lot of people will get it right. I can even try it if I wanted to. I doubt a lot of people will get it right because of the sheer variety of the topics. It's not hard by no means. It's like GE level stuff. I should think about it. It's not GE level stuff on some parts of it. Some parts of it is not GE level. Some parts of it are pure torture. Um, it is. Yeah, I just thought of it. No, it's not GE level stuff. Thinking about it. So we do um, want to talk about this. This is a topic. Actually, I don't think I showed you a sample of this. So let's go on with it. The integral of sine 4x. I'm just putting in a random variable. Cosine x dx. Can you solve it? Most people say no, blah blah blah. Or you use trig identities. Oh, by the way, if you want to prove a trig identity super easily without having to go through all the hassle, a lot of them you can do convert it to E format over here. Um, some of it, actually, not all of it, but some of it you can't. But the double sine angle formula, you can definitely prove it with these facts. So let's see which ones I can prove here. This one I can definitely no, that one I can't prove because it's like this one, right? You can definitely prove it with that, can't you? Actually, I never tried it before. Let's try that after I do this. Um, this is converted to E, and I'll explain why this works later. Hopefully, unless I forget, and I don't really care if I forget. Let me see if I can actually remember this from memory. Because last time I had to use the freaking embarrassment mode where I forgot how to do this entirely. So I do E to the fuck. Fuck. 5ix, right? And then is minus E. I think it's plus actually. Uh, yeah, it's plus, it's not minus. Then it's 3ix. It's not negative. And then you do the next one, which is minus E negative 3ix. And then again, it's minus E negative I negative 5. So 5ix divided by 4I. Am I correct about that? Hopefully I am. So I take out the 2 over here to make it into that format, 1 divided by 2, and then I could say it is E to, you can move this, you can configure this differently. So I'm trying to configure it right now uh, by grouping the 5 and 3 together in my head. I think it's something like this. No way. And then minus, I think. Yeah, you just got to wing it a little bit. Now this turns to 2i because you move it out with the distributed property. E 3ix because you have a negative. Let's put that as a positive. We can leave it as negative format. Negative 3ix parentheses, and this is actually 5. So that turns to 1. I might be wrong. Because I feel like I might have made a mistake here. Plus sine 3x. The reason it works is if you go to Desmos, and I'm assuming you know how to multiply polynomials because the way I did it was basically poly multiplication, which if you don't know it, it does not mean you're behind. It means your teacher hasn't taught you this, and I'm just embarrassed for you kind of situation. So it's Um, so this is what the poly explanation is. It is FOIL method usually we use. In reality, FOIL method is just a dumb way to make an acronym. In reality, you have to get this instant. It's no longer you have to wait a few minutes and get it right. You have to just not instantaneously, but you need to know like how to do it without someone telling you the FOIL method. Oh, use the FOIL method. No. You just have to know how to do it, and it might be funny when I'm talking about calculus in here, but it's funny. um, but this might look similar to partial fraction because in reality the concept they use is the same for both kind of. The result you want is the same as what you get, and I don't even know the answer to this. So 4x. If this is right, I don't know. So how you check it's right is you have to pretty much graph it, which I'm not willing to do by hand. Are you insane? Um, no psychopath will be willing to do that shit. Um, you could pay me $500 and I wouldn't do it. You're crazy. I never agreed. I think it was 3x, right? Got it. Yeah. So you can see that they're the same. Like if I put this into each other, they overlap each other, and you can't really see the other one without clicking off. So I got this one right. Yeah. So this is objective reality. This cannot be false. But what does this tell me? This function equals this function, which means the lines are the same. So guess what? If I take the integral of this, it's the same integral as this because the lines are the same. And what is the definition of integral? It's all the lines in here. Why we said that was it was an antiderivative. A derivative was the tangent line over here and the magnitude of that converted into a graph format over here. If I do this, this goes into here and this goes into here, and making an infinitely small arrow that makes into a graph. Graph. So what I'm saying here is that this integral should equal this integral. Now thinking about it, we can totally add this question over here. What? You didn't expect me to not add the question after I did that. Oh, we had some evil questions here. You know what? This question is too evil for me. We're gonna change that because I don't like this question. Um, to this question for x cosine. No psychopath will give that question. I'll be honest. No professor is psycho enough to give you that question. Wow. I'm embarrassed now. These two questions are so similar. Now let's just add 10 over here because that's easy. You're just gonna add 10 to over here, which means it's gonna be divided by half later. Which means that the objective reality is 5 sine 5. You know what I mean. I don't need to write it out. Why am I writing it out? I'm not stupid enough to do that. And we know the antiderivative of this is cosine 5x divided by 5. Oh wow, that actually works out perfectly. Minus, wow, this is actually, wow, that's so weird how that turned out to that. I wasn't expecting that at all. Um, definitely was not expecting that. That's a happy luck incident. But you can see this should be the integral of that original phrase we made. Another integral that another thing to know is a derivative. If I were to give to you 10, you know what? Let's make a question like that here. Um. Oh, what did I write here? Let's just do insert row below. That by this logic, if I were to give you the same graph and were to tell you get the solve get the insert new, it's not gonna cause anything problem. No, it's not. Okay, good. If I were to give like d dx, and then this will go away. That function, you should be able to do that with the same charisma as before. Um, you know what? I don't even know the answer to this. I'll have to develop the math later, but it'll be painful. But that's fine. I'll do that later to get the answer keep up and running. I don't like another sign. Yeah, why not? Why not? Oh, why I don't like another sign is sine gives. Cosine will give you a cosine. Sine will give you a cosine. Sine and cosine will give you sine. You could kind of I forgot the whole method, but you can. There's a rule to it that you can figure out by because of the properties of the e to the ix. But I forgot about it, so um, cry me a river later. So the next thing I want to do is a derivative of this, dx of 5 sine 5x, which is going to be like that, and then 5 divided by, sorry, what I meant, actually, this doesn't make any sense. So 10 sine 4x cosine for x, this derivative will just be equal to the derivative of this section over here. Um, Let me get this out, this section over here, because the lines are the same. So you could say a derivative of that would be what? What would that be a derivative of? Let's see. 1.5 would remain the same buffer. No, 5 would be the buffer because because I transposed the 5 somewhere, so 5 would be the buffer. It'd be cosine 5x5 by the chain rule, which you have to memorize later on as objective reality due to the property of limits that I didn't talk about at all, which I probably should have, like a dumbass. Um, and I don't even know where it is. Great. You're gonna have to figure it out later. It's objective reality, so it's something that's true. And I don't know where I put the proof for that is. I definitely have a proof for that. The chain rule. Is this it? So, because of you can read this, but this is the definition of a derivative. And by doing one by one, you can see that this is true, which means that this is true, which means that this whole section is true, which means it's gx, and then you can finally say that this equals this. But in reality, I just show the proof. A lot of people, if you understand the proof, if you look at the proof and see a proof, I find that they are more willing to follow it, even if they don't understand it. They know there's a proof out there that can prove this. So yeah, so we're gonna let it go, and yeah, totally let it go. Cosine 3x multiplied by 3, and that's it. And then you can say it's 25 cosine 5x, and you can say it's, and then plus 5 divided by 3 cosine 3x. You can see how you can get this into this form. Not this into this form. That doesn't make sense. This section over here has a derivative and integral by this rule, and proven by Desmos because we know that if a line is the same. Actually, let's explain the integral very easily. Now, I already said that these two lines are the same, so we can confirm that they're the. Oh, what happened there? I didn't expect that to happen. That was not something that was supposed to happen. Uh, I don't know why that happened. We'll see how that turns out. Whatever. We can also upload. I feel sick a little bit. No. So I refuse to take. So why this works is if I want a derivative of this, what's happening is that at this point you're getting a tangent. You're getting the tangent, and you're getting a tangent, and you're seeing how fast um, this moves down, really, right? Now, thinking about it, a lot of people won't understand it. The most easiest way to understand it is time and some displacement. But then I can't really express the integral of that because it has no objective reality on in reality. It has a mathematical reality. Velocity. I don't even know how to spell velocity